Welcome back to Codeverse. In today's video, we're entering one of the most powerful concepts in C++ programming, classes and objects. You've probably worked with variables, functions, arrays, but real-world programs need more than just storing data. They need structure, behavior, and the ability to model real things. That's where object-oriented programming, or OOP, comes in, and in C++, it all starts with classes and objects. Whether you're building a game, a banking app, or an inventory system, mastering classes will unlock a whole new level of coding potential. So grab your keyboard, and get ready, because today, you'll learn how to create your own data types, design your own behaviors, and truly code like a software architect. Before we dive into code, let's break it down. In C++, a class is like a blueprint. It defines the structure and behavior of something, like a template for a car, a student, or a bank account. It tells the compiler what kind of data this thing holds. We call those member variables. And what actions it can perform, we call those member functions or methods. Now, an object is simply a real thing made from that class, just like a car built from the blueprint. You can create as many objects as you want, and each one will have its own copy of the data defined by the class. So think of it like this: class equals design. Object equals actual product. This is the foundation of object-oriented programming, and once you master this, you'll be able to model anything in code, real-world people, systems, or even abstract concepts. Now let's see how to actually declare a class in C++. The syntax is simple, but powerful. We start with the keyword class, followed by the name of the class. By convention, we use Pascal case, like car, student, or bank account. Then we open curly braces and define what this class contains. Inside, we can declare variables, called member variables, that store the state or properties of the object. We also define functions, called member functions or methods, that describe what the object can do. Here's the structure: class car. Public, string brand, int year, void start engine. Cout, engine started. End L. The public keyword means everything under it can be accessed from outside the class. Later we'll talk about private and protected as well. But for now, you've just created your first custom data type. That's what a class is, a type you define, with its own data and behaviors. Inside a class, we define two main things: member variables and member methods. Member variables, also called data members, are just like regular variables, but they belong to each object created from the class. For example, in a student class, you might have string name, int age, float grade. These hold the data specific to each student object. Then we have member methods, also called functions inside a class. These define what the object can do. For example, you might add a method like void displayInfo. Cout name grade endl. This method can use the object's own data directly, because the class has access to all its member variables. You can define as many variables and methods as you need to model your object. And remember, these aren't just functions floating in your code. They are bound to your objects. That's what makes classes so powerful. They combine data and behavior into one reusable, organized unit. Alright, now that we've built a class with its own variables and methods, it's time to bring it to life. That's where objects come in. In C++, a class is just a blueprint, a design. But when you create an object from that class, you're saying, hey, I want an actual, working thing based on this design. So how do we do that? It's simple. Just write the class name, followed by the object name. Like this: student S1, here, S1 is a real student object, based on our student class. And yes, you can create multiple objects from the same class: student S2, student S3, now you've got 3 student objects, each with their own data and their own version of the displayInfo method. That's the magic of OOP. Each object is independent, but all follow the same rules defined in the class. Once you have an object, you can use the dot operator to access its members. s1.name equals Alice, s1.age equals 20, s1.displayInfo. This calls the method on s1, not s2, not s3. Each object holds its own state, that's called encapsulation, and we'll go deeper into that soon. Creating objects is the core idea behind object-oriented programming. It lets you model real-world things, like students, cars, books, users, all as independent entities with their own behaviors and attributes. So next time you write a class, think of it as a factory. And every object you create, it's a new product from that factory, ready to use, customize, and call to action. Now that we've created our objects, it's time to make them do something. In C++, you access the data and functions inside an object using the dot operator, just like opening a toolbox. Let's say we have this class student. Public, string name, int age, void displayInfo. Cout name is age. Now we create an object, student s1. Here's where the dot operator comes in. We can now set values for s1 using s1.name and s1.age. s1.name equals Alice, s1.age equals 20, and if we want to call a method, we write s1.displayInfo, boom, the dot operator lets us reach inside the object and control it. Each object you create has its own version of the class's variables and methods. So if you create another student, student s2, s2.name equals Bob, s2.age equals 22, s1 and s2 are now two completely separate students with different data, but the same behavior. This is where object-oriented programming shines. The class defines what an object can do. The object is the actual thing doing it. You can even call the method right after assigning the values. s2.displayInfo, this prints out the info for Bob. Using the dot operator is how we give life and action to our objects. They're no longer blueprints. They're active, dynamic pieces of your program. Remember, the object's name comes first, then a dot, then the variable or method. Easy to write, powerful in effect. Let's talk about constructors, one of the most important features of any C++ class. A constructor is a special function that runs automatically when you create an object. Think of it like the startup script of your object. By default, C++ gives every class a constructor, even if you don't write one. But most of the time, you'll want to create your own so you can initialize data properly. Here's an example, class student. Public, string name, int age, constructor. Student, string student name, int student age. Name equals student name, age equals student age. Void displayInfo. Cout name is aged years old. End L, notice that, the constructor has no return type, not even void. Its name is exactly the same as the class name. Now when you create an object, you can pass values directly, student s1, Alice, 20, boom. The constructor runs immediately and sets the name and age. That's powerful, because you avoid writing separate lines to initialize each variable. It also ensures every object starts in a valid state. No uninitialized values. You can create multiple constructors too, with different parameters. This is called constructor overloading. Student. Name equals unknown, age equals 0. Now you can do this too, student s2, uses the default constructor. So, what's the big takeaway? Constructors simplify object creation. They make your code cleaner, safer, and more reliable. And they run automatically whenever a new object is born. In short, constructors give life to your objects, they're like the delivery room for your data. Alright, it's time to bring everything together in a live example. We're going to build a simple class called book, and then create a few book objects to see how everything works in practice. Step 1, declaring the class. Class book. Public, string title, string author, int year, constructor. Book, string t, string a, int y. Title equals t, author equals a, year equals y. Void display info. See out titled by author year and L. Here's what we've got: 3 member variables, title, author, and year. A constructor that initializes them when the object is created. A method called displayInfo, to print the book's info in a friendly format. Step 2. Creating objects. Int main. Book B1, 1984, George Orwell, 1949, Book B2, The Hobbit, J.R.R. Tolkien, 1937, B1.displayInfo, B2.displayInfo, return 0. We create 2 objects, B1 and B2. Each one calls the constructor automatically when it's born. Then we call displayInfo on both, and boom, the output is printed. Output example, 1984 by George Orwell, 1949. The Hobbit by J.R.R. Tolkien, 1937. It's that simple. You just define a class. Add variables and methods. Use a constructor to initialize. Then create and use objects with ease. So far, you've learned to design custom data structures, encapsulate logic, and organize code like a pro using classes and objects. This is real-world programming, and it forms the backbone of larger applications. Next up, it's time for a quick mini-quiz to test what you've learned. Awesome work so far. Now let's test what you've learned with a quick mini-quiz. Each question is a chance to reinforce your understanding of classes, objects, constructors, and methods. Question 1. What is the purpose of a constructor in a C++ class? A. It destroys the object when it's no longer needed. B. It initializes the class variables when an object is created. C. It copies objects from one class to another. D. It prints information about the object. Correct answer, B. Constructors are special functions that run automatically when an object is created. They're used to initialize data members. Question 2. Which line correctly creates an object from this class? Class car. Public, string model, car, string m, model equals m, car my car equals car, Toyota, B, car, Toyota equals my car, C, car.model equals Toyota, D, car my car. Correct answer, A. This line creates an object and calls the constructor with Toyota as a parameter. Question 3. Which statement is true about member functions in a class? A. They must always return an int. B. They cannot be called from main. C. They define what objects of the class can do. D. They are written outside the class body only. Correct answer, C. Member functions, also called methods, define behavior. They tell what an object of that class can do. Well done. Mini quizzes like this help cement your knowledge and spot any weak spots early. Now, let's head to the final challenge, your turn to apply everything in a hands-on exercise. Awesome work making it this far. You've now learned how to create your own classes, define constructors, and use methods with objects. Now it's your turn to put that knowledge into action. Your final challenge, create a class called smartphone that includes a string variable for brand, a string variable for model, an int variable for storage GB. Add a constructor that sets all 3 values. Then, write a method named showSpecs, that prints out the phone's details like this: brand, Samsung. Model, Galaxy S21. Storage, 128 GB. What to do in main, create 2 smartphone objects with different values. Call showSpecs on each one. Make sure the output displays the correct information. This challenge is a great way to practice what you've learned, designing your own class structure, creating meaningful constructors, writing methods that operate on object data, and reinforcing your understanding of how C++ handles data plus behavior. Take your time, code it out, and don't be afraid to experiment a little. That's how you truly master programming, by building things. When you're done, you'll have a complete class-based example built from scratch, and a solid foundation for everything that comes next in your C++ journey. That's it for this video. Thanks for watching, and great job sticking with it till the end. Awesome job! You've just completed one of the most important lessons in your C++ journey. By learning classes and objects, you've unlocked the true power of object-oriented programming. Now, you know how to define your own custom data types. Use constructors to initialize data. Create objects that combine data and behavior. And call methods to make objects do things. These are real-world skills used in professional software development every single day. Up next, we're diving into a powerful concept that builds on everything you've learned, inheritance in C++. You'll learn how to reuse code, create base and derived classes, and make your programs more efficient and scalable. Don't miss it, it's where things really get exciting.